In the space of science and enormous, favored experiences, the subject of what existed early on to the enormous effect has sparked mixed discussions and charmed thinkers for a long time. This monumental question doesn't just test how we understand the universe, it challenges the very limits of human knowledge. Imagine standing at the edge of existence, looking into the vast unknown, and wondering what lay there before our universe was conceived. The event of the Big Bang marked the beginning of history, space, and everything we know. However, was there a moment before this? Could there have been a state of nothingness, a silence before the grand event began? Or perhaps, something even more profound existed before time itself? As we delve deeper into this question, science takes us on a journey beyond the origins of the universe into ideas that challenge our understanding. Physicist Brian Cox, known for his commitment to exploring the wonders of the universe, suggests that something astonishing may have existed before the Big Bang. He urges us to rethink our understanding of reality and existence. In this exploration, we will break down the science, the theories, and the fascinating secrets that might explain what existed before everything. We will examine concepts such as cosmic inflation, quantum fluctuations, dark energy, and even the possibility of multiverses. The revelations may be overwhelming, but they could also open new perspectives on our place in the universe. Prepare to dive deep into a realm beyond imagination and science, where darkness still lingers in the shadows, leaving scientists both in awe and, at times, unsettled. Let's examine what existed before the Big Bang and why these theories challenge everything we thought we understood. To appreciate what may have existed before the Big Bang, we must first understand what the Big Bang actually was. According to scientific understanding, the Big Bang refers to the moment when the universe became extremely hot and dense, rapidly expanding to initiate the formation of all matter, energy, and fundamental forces. When we gaze at the night sky, we see evidence of this explosive beginning, with galaxies moving outward from an initial point. But why did this happen? Was there a time before this dense, hot beginning? According to the theory of cosmic inflation, there was indeed a before, and it was far from empty or quiet. Cosmic inflation suggests that before the Big Bang, the universe was in a state that was cold, empty, and vast, much like a cosmic vacuum. However, this vacuum wasn't truly empty. It contained an immense amount of energy that fueled the rapid expansion of space itself. This process, known as inflation, happened so rapidly that it essentially set the stage for everything that followed. In an instant, space expanded at unimaginable speeds before slowing down, allowing energy to transform into particles and the forces we recognize today as the Big Bang. But what was the nature of this energy? Where did it come from, and why did it suddenly ignite the universe? More intriguingly, why did it stop? Some scientists believe that cosmic inflation created patches of the universe, each undergoing its own Big Bang. Imagine a fabric stretching infinitely, with bubbles forming within it. Each bubble represents a universe, including our own. This idea, called the inflationary multiverse, suggests that countless Big Bangs could have occurred, resulting in an infinite number of universes. This mind-bending possibility challenges our understanding of the universe itself and raises an even bigger question. What else is out there? The concept of nothingness before the Big Bang remains hypothetical. However, based on our current understanding, even if all energy, particles, and radiation were removed from the universe, it would still not be truly empty. Our universe is filled with dark matter, dark energy, quantum fields, and fundamental forces. Even in its most barren state, space itself has properties, rules and constants that prevent it from being completely empty. Imagine creating a region with absolutely nothing, no particles, no radiation, and no energy, except for quantum fields and universal constants. These would still exist, suggesting that even nothingness has properties. For instance, there is a concept called zero-point energy, which represents the lowest energy state of quantum fields. Even in this state, particles can still appear and disappear, creating a mysterious resonance of activity even in what should be empty space. This challenges our idea of a true void and suggests that, yes, even before the Big Bang something existed. Scientists are still grappling with this possibility, considering it one of the most astonishing ideas in modern cosmology. The possibility of eternal creation. If inflation could create our universe, could it also be an ongoing process? Brian Cox describes a fascinating inflationary multiverse where universes are continuously formed and expanded. Imagine each Big Bang as a spark igniting another universe while inflation occurs in different regions, creating countless other universes. This process could, in theory, continue forever. This idea of universes giving rise to other universes leads to an intriguing notion: a fractal universe, where each new universe may, in turn, create its own Big Bang. Each universe would exist as an independent realm, unaffected by the others. Considering the rapid expansion of space, this hypothesis excites and unsettles scientists alike. It suggests an infinite multiverse with no clear beginning or end. Imagine our universe being just a tiny speck in a vast, endless web of realities, continuously forming and evolving. And what if this is the true nature of existence? What if there is no definitive before or after, only an eternal pattern of universes forming and expanding? Quantum fields and the nature of nothingness. Our understanding of nothingness changes when we consider quantum field theory. According to this theory, the universe is not just a collection of matter floating in space. It is a complex network of energy fields that permeate everything. These fields act like invisible oceans, with particles behaving like waves or disturbances within them. Even when these fields are at their lowest energy state, known as the vacuum state, they are still active. Particles can spontaneously appear and vanish in these fields, borrowing energy before returning it. This phenomenon gives rise to virtual particles, entities that exist for a fleeting moment before disappearing. The existence of virtual particles challenges the very idea of an absolute void. Even in an empty universe, where all matter, radiation, and energy are removed, quantum fields would still persist. This constant activity suggests that the universe does not conform to our traditional understanding of emptiness. Instead, these fields and forces ensure that true nothingness is impossible. Could the universe have emerged from nothing? If quantum fields generate particles, and particles create matter, could the universe itself have emerged from this so-called nothingness? Dark energy, the mysterious force driving the accelerated expansion of the universe, may hold clues to this question. But did dark energy exist before the Big Bang? As indicated by specific viewpoints, the truth that dark energy exists today is a delayed consequence of an energy field from before our universe's development. The properties of dark energy appear to suggest a massive, mysterious force that may have existed in some form before the Big Bang. Some theories suggest that dark energy, in a much stronger state, could have controlled the inflationary stage, causing rapid expansion. The presence of dark energy suggests that even if our universe were emptied of all matter and radiation, this force would continue to shape the fabric of space-time. This thought leads to a profound question. If dark energy was present before the Big Bang, could it have ultimately shaped the conditions that led to the birth of our universe? Could dark energy be the silent architect of expansion or even the true beginning of our universe? As we explore this possibility, we face the potential that dark energy is not just a force shaping our universe but a key that could unlock the secrets of the multiverse itself. Another theory, cyclic cosmology, offers an alternative to the Big Bang as a definitive beginning. This theory proposes that the universe undergoes massive cycles of birth, death, and renewal. In this model, the Big Bang is not a one-time event but rather part of an eternal cycle where universes expand, collapse, and then regenerate in a new cycle. This theory suggests that our universe could have been reborn from the remnants of a previous universe. The process of contraction and expansion in a cyclic pattern implies that there was never a true beginning, only an everlasting sequence of universes emerging, creating, and renewing themselves over and over again. Cyclic cosmology raises profound questions about time, as it suggests that time itself could repeat rather than progress linearly. If this theory is correct, it could mean that what existed before the Big Bang was simply another version of the universe, one that collapsed only to give birth to our current universe. For scientists, this theory offers a compelling answer to the question of ultimate origins, implying that there is no singular beginning. Instead, the universe has always existed in some form, transcending our conventional understanding of time and existence. Gravitational waves provide another fascinating avenue for exploring what existed before the Big Bang. Discovered in 2015, these waves are ripples in spacetime caused by incredibly massive objects like black holes or colliding neutron stars. They can travel vast distances, carrying information about the events that created them. Could gravitational waves offer clues about the birth of the universe? Some physicists suggest that gravitational waves originating from before the Big Bang might provide insight into the state of the universe before cosmic inflation began. If these waves from the early universe exist, they could leave imprints that help us determine whether the Big Bang was truly the beginning or if there were grand events preceding it that we have yet to understand. These waves could be remnants of occurrences beyond our conventional knowledge. Their existence might even hint at a larger structure beyond what we currently perceive. If detected, these faint signals could unlock insights that transform our understanding, much like the discovery of the Big Bang itself. What if gravitational waves reveal traces of a past universe or an event that took place before the Big Bang? As scientists continue to probe the deepest reaches of space, the question remains: what existed before the Big Bang? With modern theories pointing to quantum mechanics, multiverses, and cosmic inflation, we are closer than ever to unraveling the profound mysteries of the universe's origins. While a definitive answer remains elusive, our understanding of what came before the Big Bang continues to evolve with every new discovery. As we explore these theories, we must also consider how they might fit together to reveal the bigger picture, the true nature of existence itself. Until then, we are left with a mystery that drives scientific inquiry, pushing us into the unknown, far beyond what we have ever understood. As we keep investigating the question of what existed before the Big Bang, time itself becomes increasingly difficult to grasp. Time as we understand it began with the Big Bang, making the concept of before it somewhat paradoxical. If time itself did not exist before the Big Bang, can we even discuss something existing prior to it? Some theories suggest that time might not have a definite starting point and that our perception of it could be limited by the current framework of physics. One of the most intriguing aspects of these theories is that they open up the possibility of new laws of physics, ones that are not yet discovered or even conceivable within our current understanding. If the universe as we know it began with a Big Bang, and before that there was a state of nothingness or cosmic inflation, then what governed the forces and particles in that pre-Big Bang state? Could there be a fundamental layer of reality that transcends time and space, where the conventional laws of physics completely break down? This mysterious realm would challenge everything we understand about the universe, yet it might hold the answers to some of the most profound questions. Some researchers have speculated that the birth of the universe might not have been a singular event, but rather the result of interactions between higher dimensional forces. According to string theory, for instance, the fundamental building blocks of matter are not point-like particles but one-dimensional strings vibrating at different frequencies. These strings could exist in higher dimensional spaces beyond the three-dimensional space we can observe. If this theory holds any truth, then our universe might be just one slice of a higher dimensional space that interacts with others, forming the multiverse. In this scenario, the Big Bang could represent the intersection of these dimensions, leading to a continuous cycle of universes being created and destroyed in higher dimensions. Similarly, theories such as the ekpyrotic model propose that our universe may have resulted from a collision between two higher dimensional branes, membranes of spacetime that exist in multiple dimensions. If such collisions occurred, they could have triggered a Big Bang-like event, initiating a new cycle of expansion and contraction. These models provide a framework for understanding the origins of the universe that does not rely on a single, distinct beginning. Instead, they present a vision of perpetual rebirth through cosmic events. This idea challenges traditional thinking about the start of the universe and opens up possibilities for how it might evolve in the future. There are also intriguing connections between these cosmological theories and philosophical questions about the nature of existence itself. If time, space, and matter have always existed in some form, does this imply an eternal and infinite reality beyond our perception? Or are we merely part of an endless cycle of creation, expansion, and destruction? Some have even suggested that the answers to these questions lie beyond the realm of science entirely, and may only be fully understood through metaphysical or even spiritual inquiry. This implies that the limits of Human understanding may not just be about technological advancements in physics but also about the profound existential nature of reality itself. In conclusion, while we may never fully answer the question of what existed before the Big Bang, the theories and ideas surrounding it provide a rich tapestry of possibilities. As our understanding of quantum mechanics, dark energy, and cosmology continues to grow, we may inch closer to uncovering the true nature of existence, time, and the universe itself. Whether the answer lies in science, philosophy, or something entirely beyond our comprehension, the mystery of what came before the Big Bang continues to captivate and inspire humanity's pursuit of knowledge.